Let me introduce myself. My name is Pietro Grottoli, and I'm the head of the Lauma Sales Department. And today I will be your speaker during this webinar dedicated to PLC and Fieldbus. Okay, I think we are almost ready to begin. So, first of all, why this argument, PLC and Fieldbus? Let's say that we have chosen this argument because we think that nowadays it's a very topical issue. And because we find that many of you still make confusion both in identifying the Fieldbus suitable for your needs and also in inserting the devices within a PLC project. So this presentation will be divided in two main phases. The first one, a more theoretic one, during which we will try to provide you basic information both about the subject in general and about what Laumas can offer you in terms of products. Then we will have a more practical one. In the second phase, through a video, we will create the basis of a project on a PLC, and we will insert in this project our TRB weight transmitter connected via Profinet. Okay, I would say that this introduction is gone, so we can start with our real presentation. So, first of all, let's have a short introduction about what a Fieldbus is. The original source of this text is Wikipedia. That is always very useful when we have to learn the basis of any argument. So let's read this slide together. Fieldbus is the name of a family of industrial computer network protocols used for real-time distributed control. A complex automated industrial system usually needs a distributed control system, an organized hierarchy of controller systems to function. So, in this hierarchy, there is usually an HMI at the top, where the operator can monitor and operate the system. This is typically linked to a middle layer of PLC, that means programmable logic controller, via a non-time critical communication system. At the bottom of this control chain, there is the Fieldbus that links the PLC to the components that actually do the work. So here we are. We are the junction between the PLC and the sensor. As a company specialized in weighing, and in particular in process weighing, we take care of connecting load cells to the PLC. It means that we are a link in the chain of a complex automated industrial system. Well, take note that all that we will show you and explain you during this presentation about Fieldbus is just referred to the weighing world and in particular to our specific experience, because we haven't a shared database with our competitors. What we can say for sure is that in the past, the main part of the connection between load cells and PLC were made via analog signal, so amplifying the millivolt volts coming from a load cell to 0 to 10 volts or 4 to 20 milliamps, for example. Frankly speaking, in our sector, analog amplifiers are still very popular. Just to give you an idea, in the 2019, we produced about 34,000 electronics, and 45% of it, so about 15,000 pieces, have the analog output on board. But in any case, we can see that things are changing, and we can see it with our own eyes. Maybe a little bit on delay if compared with other sectors. Even in the weighing world, things are changing, and the Fieldbus are becoming more and more popular. All the biggest and most popular PLC producers developed their own field bus communication protocol. Because of this, plant manufacturers and automation companies are chained to the PLC producer, given that every component installed in the plant has to pick the same language as the PLC. At the same time, if a complex automated industrial system is composed by hundreds of parts speaking all the same language, it will make things a lot easier, both for the programmer and for its own management. Okay, so many PLC producers produce specific weighing modules compatible with their own PLCs to handle the signal coming from the load cells. We, as Laumas, as specialists in process weighing, developed a wide range of weighing electronics compatible with all the field bus, in order to be as versatile as possible and to offer to our customers the possibility to install Laumas products regardless of the PLC or the field bus to be used. Here we can see a simple panoramic of our weighing electronics with integrated field bus. As you can see, we can offer a big variety and many solutions for any installation methods in order to satisfy our customers' needs. So, as I was telling you, we can offer any method, any installation method to satisfy our customers. Certainly, in process weighing, the most typical installation is on the array. So, our most popular products in this sector are the weight transmitters series TLB, TLB4, and TLM8. But in many other cases, the customer needs to visualize the weight and to install the indicator in different ways. So here we are with the other solutions. We have our LCD that is a digitalizer and that can be connected directly to the load cell. We have indicators for front panel mounting, indicators to be installed in hazardous area, indicators to be installed to the wall. So we have many solutions. The reason is that the versatility is a must for us, even when we talk about field bus. And let's go back to the field bus. Here we can see all the field bus managed by Laumas. There is a big list, as you can see in our slide. I don't want to look arrogant, but we are probably one of the few companies worldwide managing so many of them. Some of them are very popular and very well known. For example, if we talk about Profinet or Ethernet IP or Profibus or Ethernet TCP IP. And some others are not so famous, like for example, PowerLink or Circus3 or stuff like that. In any case, if a system integrator looks for a weighing device, even for that niche market, can find in Laumas the right partner, because we can offer the solution to develop his project. So field buses can be divided in two main families. We have field bus and we have industrial Ethernet. With the field bus, the connection is usually done by a wire to our connector or to a terminal board. And buses like DeviceNet, Profibus, Canopen, CC-Link are all field bus. For the industrial Ethernet, the connection is done using a coaxial cable and an RJ45 connector, like the one that we have on our PC. Profinet Ethernet IP, Ethernet TCP IP, Modbus TCP, and all the rest of the list that we can see are industrial Ethernet. In any case, to simplify our lives, we always call all of them field bus. Okay, here in this slide, we can see the significant growing during the last 8 years in our sales of electronics with field bus. We start from about 1,100 pieces in the 2012 to reach about 8,600 pieces in the 2019. So we have a constant growth that is about an 800%. So it's not a few. As we can see in the graphic, the most popular for us are certainly Profinet IO and Ethernet IP. But in our special ranking, let's say, down to the position number 7, where we find the CANopen, they all look very relevant for us in terms of sales. But I repeat, this is referred to our actual sales volumes. It's enough, for example, that we find a new partner that is used to install Mitsubishi PLC, and we will see the CC-Link that in this moment is not so relevant. We will see the CC-Link growing and growing very quickly. In the last year, as we can see in the slide, we have seen a big growth in the utilization of protocols like Modbus TCP and EtherCAT, for example. So it means that these data are constantly evolving. An important side note about this slide and this graphic is that we have excluded from our calculations the protocol Modbus RTU. The main reason is that almost all of our electronics have it on board as standard. So we don't know how many of our customers are really using it during their installations. We are certainly talking about thousands and thousands of pieces per year, because the Modbus RTU protocol is, we can say, an old, well-known, and cost-effective protocol. But I repeat, we cannot monitor this data as we can do with all the other field bus. In this slide, we can see our field bus market share in percentage in the 2019, so during the last year. It is evident and clear that Profinet and Ethernet IP are the leaders for us. But even TCP IP, Profibus, Modbus TCP, EtherCAT, and CANopen are quite relevant. And what we have seen in our sales and in our sector is also confirmed by HMS. HMS is one of the world leaders in the supply of solutions for industrial communication. Even for them, Ethernet IP and Profinet are the leaders, and the protocols on Ethernet base are constantly growing if compared with the field bus. Anyway, they cover a very, very big market, a very, very big share. So we can see many protocols shown in this slide that are not so popular or not so relevant in the waving world. Now, we can take a look at the biggest PLC producers and at the field buses developed or mainly associated to these companies. Keep in mind that in any case, this is just a rough guideline, because in the truth, if you are ready to pay money for additional boards, you could get almost any field bus with any PLC brand. Even if we can say that some associations are quite uncommon. As for example, a Siemens PLC, Ethernet IP.
Il cellulare vicino qualcosa che fa interferenza.
Okay. Keep in mind that there are also many other PLC producers that are not mentioned in this slide, as for example, Vipa or LG or Panasonic or Samsung or Hitachi, so all of them are PLC producers. And there are many, many others. But we have taken in consideration just the ones that we hear more often in our sector and the ones that developed their own field buses. So we have Siemens with Profinet and Profibus, Allen Bradley with Ethernet IP and DeviceNet, Omron with EtherCAT, Schneider with Modbus TCP and Ethernet IP, B&R with PowerLink, and so on. Based on the data that we have seen before, we can see that the PLC leaders are mainly two: Siemens with Profinet and Allen Bradley with Ethernet IP. And to simplify, we can say that Siemens is stronger in Europe, while Allen Bradley is stronger in North and South America. Then we have three main outsiders, but outsider is not the right word. So we have other three main PLC producers, very famous worldwide, that are Omron with EtherCAT, Schneider with Modbus TCP, and Mitsubishi with CC-Link. Mitsubishi, for example, in Europe is not very popular, but if you move to the Far East, and in particular to Japan, for example, you will find thousands of applications made by Mitsubishi. In Europe, I repeat, it's not so popular, but maybe it will come, who knows. In any case, it is very important remembering this association, PLC and Fieldbus, when it's time to talk with your customer and to define the correct protocol to be used. Now we can talk about the Ethernet TCP IP, and this kind of protocol deserves a separate discussion. It is not a protocol for PLC connection, and it was not developed by a PLC manufacturer. It is the protocol that we generally use to interface a device with a company network or a PC software. Said that, we can also find many PLC with the TCP IP port, but this is mainly used as service port for firmware updatings and stuff like that. In any case, we cannot exclude that someone uses it for the connection of sensors to PLC. But in any case, I repeat that this protocol was not born for the PLC. Okay, so every device and every Fieldbus has its own configuration file. The configuration file that is always included with our electronics must be uploaded onto the PLC and are necessary to allow the PLC to recognize and manage the devices within the communication network present in the automation system. Here we can find a list of the configuration file names. So we have Profinet with GSDML, Profibus with GSD, Ethernet IP with ADS, Ethernet with DAISY, and so on. When you upload the configuration file to the PLC, it is very important that you install the correct one. Even in the Laumas product range, different electronics with same Fieldbus have different files. It means that, for example, you cannot use the GSDML file of a TLB for a TLMA to a transmitter. Otherwise, it doesn't work. So it is important understanding the association between Fieldbus and configuration file, and between specific configuration file and specific device. I also remind you that all of our configuration files are available and downloadable from our website. It's enough to access with your password. As you can see in the list that we have seen before, the Modbus TCP and the Ethernet TCP IP protocol have no configuration file. The reason is that Modbus TCP has the same identical register structures of the Modbus RTU protocol, generally used on the serial port. While the TCP IP, as we have seen, is a generic interface on Ethernet base, like the ones that we have on our PCs at home or in the office. For this reason, the protocol to be used is not fixed, but is settable according to your needs. Okay, so now we should have all the information to be able to select the right Fieldbus according to our customers' needs. And in this slide, we can see the basic questions that we have to ask to our customers every time. This is really a key point, because very often the customer doesn't know what he really needs. It happens almost daily that people call us and say, I need Ethernet communication. And we ask, okay, but which kind of Ethernet? And sometimes the answer is, give me the better one. So it doesn't work like that. There is not a better or a worst. As we have seen, we can manage any field bus on the market. So everything depends on the PLC. When we know the PLC model, the producer, and the input ports available, we should be able to identify the right bus for that application. Very common errors that we see are mixing up Ethernet TCP/IP with Modbus TCP and Ethernet IP, for example. Pay attention, because all of these names are very similar. So this is not to simplify our lives, but we have to pay attention. And it also happened that maybe sometimes we receive orders for an Ethernet IP device, and after a few weeks, the customer calls us and says, I'm trying to connect your weight transmitter to my company network, and it doesn't work. So sure, it doesn't work, because for a PC connection, you need a TCP/IP communication, not Ethernet IP that is made for a field bus. Sorry, that is made for a PLC, and in particular, usually for Allen Bradley PLC. So what I mean is that to prevent such errors that mean waste of time, waste of money, and hungry customers, it is always better investigating and double checking before the sale if we are not sure of what our customer needs. Okay, so this first part of our presentation is almost finished, but before moving to the second step, we can take a fast look at our website, because when it's time to select a product in general or a field bus in the specific, because today we are talking about field bus, the use of the filters that we put on our website is always the easiest and fastest way to get a quick and correct answer. So let's try to do an example. If I open our website, okay, we can see it here. We are in the home page. We are talking about field bus, sorry. So we are talking about electronic instrumentation and very often of weight transmitters. So we can select weight transmitters. On the left of the screen, you can find many filters about protection class, power supply, display, field bus, of course, certifications available, and stuff like that. So let's do an example. For example, I need a transmitter with an IP67 protection class. I need it with Ethernet IP, and I need it with OIML approval. The selection is completed, and we have just one device, that is the TLM8 Ethernet IP. So by clicking 3 filters, we have found the right product for our application. We can do another example. For example, we can look for a weight transmitter for front panel mounting. So we select panel, and we choose, I don't know, Profinet. So front panel, Profinet, and we don't need OIML. Let's check it out. And we find that the only product, that fulfills our requirement is our TLB Profinet. So this is just to say that I suggest to play with the filters that are really, really useful and that can make your life easier in the selection of the field bus and of all of our products in general. Said that, I think that we can really move to the second phase of our presentation. So let's take a look at this video. In the beginning, we wanted to do a live demonstration about it, but unfortunately, due to the coronavirus, we cannot be there in two persons, and so we cannot do a live session. That's the reason why we have registered this video. As I said in the beginning, in this video, we will see how to implement a TLB weight transmitter in Profinet net connected via the TIA portal. So let's check out the video and see you later for the question time.
Welcome to this video tutorial about the integration of a Laumas TLB Profinet I/O weight transmitter into a Profinet network mastered by a Siemens PLC. The setup we will use during this tutorial is composed by a Siemens S7 1200 PLC and one Laumas TLB Profinet I/O. The development tool we will use is TIA Portal version 12. The required documentation for the integration procedure is composed by the TLB Protocols Manual and the TLB Profinet I/O GSDML file. A note about the documentation: for all Laumas customers, the required documents are all available on Laumas website. We can now switch to the TIA portal interface, where a project is already opened containing currently only one device, namely the PLC we will use as the network master. The first operation needed for the integration procedure is to import the GSDML file into the hardware catalog of our TIA portal installation. In order to realize this operation, we have to access to the Options menu and select Install General Station Description file. Then we have to select the folder containing the GSDML file, select the file and click to install. Once the installation is completed, we can go back to the Devices and Networks view, from where we have the access to the hardware catalog, and we can surf among the folders of the catalog to identify the TLB object. The TLB is present into the catalog as Laumas REPNS version 2.0 object. In order to include it into the project, we have to select it and drag it into the Devices and Network views and connect the PLC with the device. Now, selecting the device and accessing to the Properties section, we are able to define two very important parameters for the correct functioning of our Profinet network. More in detail, we can set the IP address that will be assigned by the PLC to our TLB instrument during the network initialization, and we can set the device name. Device name is fundamental during the initialization of the network and during the management of the devices by the PLC. With a double click on the TLB symbol, we have access to other important information. More precisely, we are able to see how the data exchanged between the TLB and the PLC are organized and addressed by the PLC itself. More precisely, here we see that a group of 8 bytes has been set into the output area corresponding to the data cyclically sent by the PLC to the device during the communication and starting at the 256 address. In the same way, we see here a group of 18 bytes defined in the input area corresponding to the data that during the communication are cyclically received by the PLC. And this group starts at the address 256. Now we can exploit this information in order to define a set of useful tags that could be exploited, for example, during the PLC software development in order to properly manage the data exchanged with the TLB instrument. Another important set of information useful for the tags definition is contained into the protocols manual. Now we can open it and open the Profinet section. Here, after a set of preliminary information, we find these two tables that show how the data exchanged by the TLB on the Profinet network are organized. More precisely, in the output data, we find all the values cyclically sent by the PLC, by the TLB instrument to the PLC, and in the second table, we find the data cyclically received by the TLB instrument. Among the data transmitted, for example, we see that we have available the gross weight value, the net weight value, and so on. Okay, so we can add a tag table, rename it, and we can start to define our tags. For example, we can define the gross weight tag. As we can see in the protocols manual, the gross weight transmitted by the TLB is a 4-byte field. And another important information is that both gross weight and net weight are transmitted as absolute values, so without the sign. We will see briefly where to find this information. So, gross weight occupy the first 4 bytes of our data. So we can define it as a UD int data type and assign to it the 256 starting address. The same way, we can define the net weight tag with the address currently proposed by the TIA portal, and we can add to these two values the status register tag. We can check on the protocols manual. Here we can see that the status register is a 2-byte field, and it is a register composed by 16 bits, each one of them with a specific meaning assigned to it. Again, in this manual, we have available a specific table listing the meanings assigned to all the bits composing the status register. And exploring this table, we see that, for example, the bit 7 value gives an indication about the sign of the gross weight value. More specifically, if during the communication we find a value for the status register corresponding to bit 7 equal 1, this means that the received gross weight is a negative weight value. In the address table, we see also that the status register bytes occupy positions 12 and 13 of this area. So we can define a status register tag as a word value, and the starting address is 268. The last tag we define is the command register. This field is a 2-byte field into the input data, and it is used to send to the instrument specific numeric command codes that allow to obtain the execution by the instrument of specific operations. Again, in our protocols manual, we have a specific table listing all the command codes defined for our TLB instrument. So, can go back here, define a command register tag. It is a 2-byte field, so we can define word as data type. But we have to change the address, switching to Q, corresponding to the PLC output data area, and we have to set the address, the starting address, to 256. Now we can exploit all these tags for test purposes, adding them to a specific watch table. We can define a new one. Name it scale test watch table. And we can start adding to it the previously defined tag. Or in particular, we can add to it the gross weight, the net weight, and the status register field. While we can verify if correctly the command register has been added to the force table. That allows to force a specific value in a field defined in the output data area of the PLC. Now we can save the project, and before going on, we can focus for a moment on the physical device. More precisely, in order to obtain a correct communication between the PLC and the TLB, it is mandatory that the name of the physical instrument in our Profinet network is equal to the name assigned to it into our TIA portal project. In this case, this means that our physical TLB has to be named as scale 1. How to do it? We can exploit the TIA portal. In the online access section, we can select the network interface used to connect our PC to the network where all the Profinet devices are connected to, and we can double click on Update Accessible Devices. In this way, we trigger the execution by the TIA portal of a procedure aimed to detect all the available Profinet devices on our network. Here we see the list populating, and among the available devices we find the PLC and this Laumas PNIO object. Laumas PNIO is the default name assigned to all Laumas weight transmitter instruments equipped with a Profinet interface. So we have to change this name to the required scale 1. To do this, we have to double click on Online and Diagnostics, and in the Functions section, access to the Assign Name, where we find the fields where to put the new name and the button Assign Name. The operation is executed. We see here the successful result. So now we can go again to the network view, select the PLC, and going on with the compile operation for our project, and we are able to download the compiled project to the PLC. We can load it. Okay. Now we can switch the functioning mode of the PLC to run. Very well. We can go online to check if all the operations has been successfully completed. Okay, all the green symbols means that all the items on our Profinet network are working correctly. Now we can access to our scale test watch table, and enabling the monitoring function, we are able to see all the data currently exchanged between the PLC and the instrument. Here we have the gross weight and the net weight values received, and the current value of the status register if we go to our protocols manual and compare the current value of the status register with the table corresponding to this field. We are able to see that the current value means that the weight value is stable. Okay, now we can access to our first table to verify the working of the command register. For example, we can ask to the instrument to execute a semi-automatic tare operation. This requires statement. This can be obtained writing the 7 command code in our command register field. So we can write the 7 value here. Check here in force and click on forcing value. Now we can stop the force and we can go back to our scale test watch table. As we can see here, we obtained the zeroing of the net weight. This means that the semi-automatic turn has been correctly executed. Also, the status register value is changed because if we see on our table, we are able to see that the bit corresponding to a net display mode is to 1. With this last test, this tutorial is completed. Thank you for your attention. See you next time. Bye.
Okay, good. So let's go back to the live of this event. We have seen this video. I hope it was helpful, and especially it will be helpful when it will be time for you to do something like that, or to grant to your customer a technical assistance during these operations. Also repeat you that this video will be available in a few weeks on our website. It's a sort of tutorial to train everybody in using, in this specific case, a Siemens PLC with one of our devices via Profinet. Anyway, it's the questions time. So if you have any question both about what we said during this session, I'm here to try to answer to it. So the first question that I got is, we would like to know what are the best applications your PLCs can be used. Well, there are no best applications. Luckily for us, weighing and force measurement are used almost everywhere. So saying that there is a best application is not correct. Everywhere you have to weigh something or to measure force, you need a load cell, you need a weight amplifier, and you probably need a PLC. So let's move on. Do you know if Laumas have any plans to support IoT protocols like MQTT or OPC UA? Let me check at what our technical department says, because I'm not a technician. And the answer is yes. So we are now working on a new hardware platform for all of our electronics, and we will also include this kind of protocols. Is there any plans to do another video for Ethernet IP users? The answer is yes. We started with Profinet because it's the most popular in Europe, but we think and we know that these tutorials are really useful everywhere. So we plan to do it for the Ethernet IP, but even for Modbus TCP and for all the main protocols. It's just a matter of time, but when the videos will be ready, we will put it on our website in the tutorial section. Then we have a question. Do the Laumas only work with the Siemens PLC? No, not at all. As I said, we manage any field bus, so we deal with any PLC. We do not sell PLC. We just sell weighing electronics compatible with PLC. So again, like I said before, we use the Siemens and Profinet because they are the most popular in Europe, but that's it. we could have done the same thing with Allen Bradley and Ethernet IP or any other PLC producer. Okay, let's move to another question. Will a weight indicator be developed for modular exchange of the diversity of bus system, and what can be used for wall mounting or table use? Well, we don't know it. Theoretically, it's feasible, so we could do it, but we never thought about it. So we have to think about it. But as I said, we are developing new hardware platforms. So any suggestion and any idea is accepted. We will think about it, and if it's feasible, we will include it. Okay, we have another question. The data register was read as an unsigned integer. Can the register be real as a real value? No. So we are always talking about real integer. Internal, sorry, internal. I was reading the message of the colleague because I repeat, I'm not in the technical department. So these are always internal values. Okay, so if you haven't any other questions, I thank you for your time. I hope it was useful, and I hope to meet all of you in better times soon. So keep safe and keep well. Bye.